Now let's take a look at some dimensional modeling. This is another key concept in data warehousing. Dimensional modeling is designed to reduce complexity. If you recall, normalization was the kind of opposite of this, where what it did is it reduced redundancy. And that's for transaction processing efficiency. Here, what we're trying to do is make it most efficient for analysts to get answers to their questions. So we can't have a really complex design that slows them down. That needs to be simple and easy for them to use. It also provides a historical view. As accounts with our customers or as our products change over time, if we want to accurately report on what that was like in the past, we have to keep a historical record of what that is. This happens through a process known as a slowly changing dimension, and I won't get into that in this module, but I will point you to where you can find more information about how that process works. This dimensional model also enables analysts. This is essentially how they interact with the data. It is the design of your database that they interact with. It's also reusable. One thing that's great about dimensional modeling, if you do it right, is that in the initial stages, it's going to be really slow to build and the cost is going to be high. But over time, you're going to be able to reuse all of those things that you built, hopefully, if you did it right, and you'll be able to then move much faster in the future. So let's talk about this. Dimensional modeling, what is it? Well, it's a technique that is focused on analysis or business intelligence. In the world of business intelligence, this is a key concept here. And why would we do it? Well, it's a great way to enable the analyst to be effective. Like I said, it simplifies things, it gives them access to clean data. And we do it by creating fact and dimension tables, creating what are known as data marts. It's like a miniature data warehouse, and some would argue that a collection of data marts is effectively what you could call a data warehouse. The semantics here aren't that important. I think what's more important is to understand how these things are designed and built. So I'm going to jump in and show you that now. So let's talk about facts and dimensions real quick. A fact or a measure is generally a numerical thing that we want to aggregate. It's the subject of the analysis, I like to think of it as, such as sales amount. We want to do a sum or an average, a min, max, median, or something like that on one of these fields, one of these attributes. Think of it like as a column from our spreadsheet that you would use in a pivot table. Well, dimension is kind of the opposite. It's the context by which we analyze our facts. So if we're looking at sales amount, we want to see sales amount by industry or by customer. The customer or industry by which we're analyzing, that's the context of our analysis, and those are what are known as dimensions. These are generally pieces of text that are categorical in nature, not necessarily things that are continuous, such as a time series. But you can think of them as just two key ingredients for good analysis.